Hello friends, I am Dr. Sarika Panwar. From today, I am starting my video lectures of 12th Computer Science subject, and this subject is of the HSC Maharashtra Board, and the subject is divided into two parts, Part 1 and Part 2. Part 1 is about the computer science C++ programming. Chapter 1 is operating system. Chapter 2 is data structures. Chapter 3 is C++ programming. And Chapter 4 is hypertext markup language, that is HTML. Now, first we will start with the part 1. But in part 1, operating system and data structures, these are theoretical chapters. So we will discuss it till later. First, we will start with the C++ programming, and then HTML, that is hypertext markup language, and then with chapter 1 and chapter 2. So this will be our flow of video lectures. Now, as far as part 1 is concerned, chapter 3 is C++ programming, and we should know before actually starting the programming, we should know the history of C++. It is developed by Jan Stroustrup at Bell Labs in 1980s. Actually, C++ is designed as an extension of C programming language. C++ program are intended for system programming, but they are widely used across the various domains. C++ is very popular language, and it is developed as an extension of C, and both languages have almost the same syntax. The main difference between C and C++ is that C++ supports the classes and objects while C does not. And because of this support of classes and objects, C++ is called as object-oriented programming language, which gives a clear structure to programs and allows code to be reused, lowering the development cost. As far as the difference between procedural programming and object-oriented programming language is concerned, C++ is object-oriented programming and C is a procedural programming language. So we will see the difference between procedural programming language and object-oriented programming language. Procedural programming language revolves around writing procedures or functions that perform operations on the data. C is the procedural programming language. In procedural programming language, the data revolves around the procedures. So the whole program, the whole application is divided into the smaller functions or procedures in procedural programming language. OP completely revolves around the object. It means actually the data revolves around the object. So the data in procedural programming is often global or passed explicitly between functions. Functions can modify the data directly, leading to potential issues with the data integrity and code maintainability. In OOP, data is encapsulated within the object, limiting direct access and manipulation. Instead of global data or passing data explicitly between functions, objects communicate through well defined interfaces, promoting data integrity and code maintainability. In procedural programming language, programs are typically designed from the top down approach, where the problem is broken down into smaller manageable procedures. In OOP, it follows a bottom up approach. So, for the demonstration of the procedural programming language, we will discuss one program in C platform. This is the program I have written for demonstration of the procedural programming language. I am using the Dev C++ programming platform. So when we write the program in C, the first compiler directive I have included is stdio.h. Why this is required? Because it is a header file, and the functions related to the input outputs are all defined in this library, in this header file. That's why we need to include this stdio, which is not your instruction, it is the compiler directive. Now this slash, if you write the two slashes and then write something, then it becomes the comment. Now the program in procedural programming language, the complete program is divided into the functions. Small functions are also called as the procedures. They are also called as the methods. So you can call it as a function, as a procedure, or a method. So here we have declared one global variable. Any procedure can use this global variable as it is, and that procedure can make changes into this global variable. Its value is initialized at 200. Now this is the integer variable. Global, it is just the name given to the variable. It is a global variable. Its value is initialized at 200, and it is an integer variable. There are different types of variable in C as well as in C++. The main types of variables are integer, float, and character. Integer occupies 2 bytes of memory, float occupy 4 bytes of memory, and character variable occupy 1 byte of memory. So if we declare this variable which is named as global variable, assign the value 200. So for saving this value of 200, it will occupy 2 bytes of memory. Now again, I am giving one comment, that is function, to add the two number. Now here I am writing the function definition. This is the call. This is actually called as the procedure. The whole program, as I have told you earlier, the whole program is divided into the procedures or functions in procedural programming language. So here, this addition program, addition function is written. The name of the function is addition. You can give any other name, it is just the identifier. And its return type, every function has a return type, and this function is written it will return the answer in integer. That's why its return type is integer. Now every function can be passed with the arguments. Now these arguments are nothing but the data on which the function will work. Here we are passing two variables, both are integer. So A is a integer variable and B is also the integer variable. It is separated by the comma, and that's why we call this as a arguments which we are passing to this function. Now, by using this integer A and B, when this function will get the values of this A and B, it will add it and it will return the answer from where it will be called. Function is a return to perform the subtraction operation, and here in subtraction operation, the subtract the name of the function is given as subtract. Okay, two arguments are passed, int a and int b. Actually, this all variables which are nothing but the arguments, these are local to this function. So the life or scope of these variables will be inside this function only. It cannot work outside the function. So here in subtract function, the name of the function is subtract. That's why I'm calling it as a subtract function. Two integer variables are passed as an argument, int a and int b. These are local to this function. It will perform the subtraction operation a minus b, and it will return the answer, and which is integer. That's why the return type of this function is int. So here in my program, there are two functions written. Definition of these two functions uh, are there, and the name of one function is addition, and the name of the other function is subtract. Subtract. These procedures, addition and subtract, these procedures will operate on these local data variables. That's why it is said that in procedural programming language, the data revolves around the procedure. Now, after writing the definition of these addition and subtract, now I am coming to the main function. In C or in C++, in both the programming platform, main function is always there, and here, and the return type of the main is integer here. Now the main function start with this opening curly bracket, and in the inside the main function, the first thing we are doing is what? We are declaring the two integer variable. The name of the first integer variable is num1, the name of the second integer variable is num2, and here the num1 is initialized at 105. So when we declare this num1 variable, the 2 bytes of memory space will be allocated for num1, and value 105 will be stored over there. Similarly, in num2, 25 will be saved, and we want to perform the addition operation and subtraction operation on these two numbers num1 and num2. Now we will not actually perform the addition and subtraction inside the main, because we have already written the definition of two functions, that is addition and subtraction. So why to do the same task again, for which we have already written the procedures or functions? So we will just call those functions. We will pass two parameters, num1 and num2, as a argument to this addition function. Here num1 comma num2, these two variables are passed as a parameter, and these num1 and num2 are the local variables. Num1 and num2 are the local variables, and their scope is inside the main function. That's why it is called as the local variable. Now, when we write the addition here, means we are calling this function, addition function, and we are passing the two arguments, num1 and num2, as a parameter. And this num1, as soon as we call this function, what will happen? This the program flow will go here at this part, and num1 will be passed to this variable a, num2 will be passed to this variable b, and now a and b will be having the value 105 and 25, which are actually the values of num1 and num2, which are local to this main function. So here uh, A is having 105 value and B is having 25 value. Both will be added, 20, 105 and 25, and answer will be returned. And where will it return after execution of this addition function? The answer will be returned over here. Okay, so we have to save this answer somewhere. So we have declared the integer variable whose name is sum. So our answer, which is returned from this function, will be stored in some variable. Now we want to uh, print the answer on the console. So we are using the printf function for the same. And in double quotes, what message we are writing? Sum colon. We can write sum equals to, sum equals to, what is percent d? Percent d is written if it is a integer variable. If your variable which you want to display is a float variable, then you can write percent f, and this slash n represents the new line. Okay, so your cursor will be moved on the new line after this display. Okay, and double quote, after completing the double quote and giving the comma, actually you have to write the name of the variable which you want to display here. Then similarly, we will call the subtraction operation, because now we want to perform the subtraction operation on the num1 and num2 variables. We have already written the procedure for the subtraction operation. So why to perform the same operation here again, when we have written the procedure, separate procedure for subtract operation? So what we have done, we have just called the function by passing the two arguments or parameters, num1 and num2. Num1 is 105, num2 is 25. Now, as soon as we call this procedure or we call this function, the program control will go here. Okay, so once the program control is here, so your a is num1, that is 105, and b is num2, that is 25. So 105 minus 25 operation will be performed, and it will return the answer in integer. So after execution of this uh, subtract function, the program control will be here, and it will return the answer which we will store in some variable. So for that purpose, we have declared the integer variable which will store the answer of subtraction operation, and that will be stored in the difference variable. So now we want to display the difference variables answer on the console. So we will uh, use the printf for that, which is used to display the message on the output console. So after giving the difference value in quotation, double quote. You can write equal to also, uh, equal to percent %d. Why we are writing percent %d? Because it is the integer variable whose value is to be displayed. And after giving the double quotes and comma, the name of the variable should be written. Okay, and in C and in CPP, in both the cases, at the end of every statement, we need to give the semicolon. Now, we want to access the global variable here by in this printf statement. So now see, global variable declared outside all the procedures. See, this global variable declaration is done outside the addition function. It is done outside the subtraction function. It is done outside the main function. Here in main function, global variable is not declared, but the main function is accessing the global variable. Main function is accessing the global variable. That's why it is called as global variable, because any procedure or any method or any function can access the global variable, because its scope is throughout the program. So any function, any procedure can access the global variable. That's why it is called as global. So we are accessing here the global variable. The same thing we did here. For access of the global variable, we have written the global equal to percent %d represents that it is the integer variable. And what is the name of the global variable? It is global. That's why we'll make change over here. It's a global variable. Otherwise, it will give you an error. Okay, now here we are ending our main function, but before closing the main function by using this closing curly bracket, we need to return 0, because our main function is not returning anything. That's why it should end with return 0. And now your code is ready to execute. So now for execution of the code, you go in execute tab and press the compile and run tab. Okay, now what we can see that since we have used the printf to display the sum of two numbers, num1 and num2, which is 130, then difference equal, it should be equal to 80, and global variable value is 200. Okay, so here the global variable value is 200. That's why it is showing 200. You can change this value, like if it is 23, and in difference it should be equal to, so it will display it as equal to. So again we will compile and run the code. And now what we can observe, that sum is equal to 130, difference is equal to 80, and global is equal to 23. Now what we can observe, that in procedural programming language, the data revolves around the procedures. So procedural programming revolves around writing the procedure. It focuses on writing the procedure. The whole program is broken down into smaller manageable procedures, and those small procedures can use the data. That's why it is said that in procedural programming, the data revolves around the procedure. And now here in our code also, we can observe that how the data revolves around the procedure. Here the data is in main program, the data is num1 and num2, these two numbers, and how these two numbers are passed as a parameter to addition procedure and subtract procedure. And those procedures, both the procedures or functions can use this data which are passed from the main program. So this is how we can say that in procedural programming language, the data revolves around the procedure. And if there is a global data, its life is throughout the complete program. That's why, though it is declared outside all the procedures, global variable is declared outside the main function, it is declared outside the subtract function, it is declared outside the addition function, but still it can be accessed by the main function. Why? Because it is a global variable. Okay, so this is how we can say that in procedural programming, the data revolves around the procedure, and data in procedural programming is often global, or passed explicitly between functions. Functions can modify the data directly, leading to potential issues with data integrity and code maintainability. Now, in our demonstration code, we have seen that how num1 and num2 variables are passed explicitly to the functions addition and subtraction. Okay, so since both the functions are using the data which is passed to those functions, there may be the potential issue of data integrity and code maintainability because those functions can easily modify the data. That's why there can be the data insecurity, there can be the potential issue of data integrity and code maintainability. So, these are the problems associated with the procedural programming language. There can be a data security issue, data integrity issue, and code maintainability issue. To overcome all these problems, the object oriented programming is there, and in object oriented programming the focus is on the object rather than on the procedure. That is all for today. Thank you, students.